Alright, this video is going to be talking about solving quadratics by graphing. So we're going to take the equations we talked about in class, and instead of just graphing them, we're going to solve the equations. So we're going to find the values of a function that would satisfy the equation completely. And we're going to do this by graphing by first setting the equation equal to 0. Now we do that because if we were to graph the equation and this equation is equal to 0, the solution is going to be where the graph crosses the x-axis. That's when the equation will equal 0. So for example, if we have the equation y equals x squared plus 4x minus 5, if we were to solve that equation, we would set it equal to 0 first, and see where it crosses the x-axis, which in this case is right here. So what we're doing is we're set the equation equal to 0, graph the parabola, and then see where it crosses the x-axis. Okay, so if the equation is equal to 0, the points that are going to satisfy that equation are going to be where it crosses the x-axis, where the y value is equal to 0. Here we have an equation, x squared minus 3x minus 4 equals 0, and we want to solve that by graphing. Remember, the first step to solving a quadratic equation was to make sure the equation is equal to 0, which in this case is the case. So now we're going to try and sketch the graph and see where it crosses the x-axis. So we're going to be sketching or graphing So we're going to graph that equation on this coordinate plane and see where it crosses the x-axis. If you remember from class, there was 4 things we needed to look for when we're graphing the parabola. First thing we need to do is we need to find the y-intercept. The y-intercept occurs when x is equal to 0. So you plug in 0 for x, and after you simplify, you should get negative 4. So our y-intercept is 0, negative 4. X's symmetry is when x equals negative b over 2a, which in this case, our b is negative 3, so negative of negative 3 is just a 3. So our x's symmetry is x equals 3 halves. Our vertex, we're going to take our x value for the x's symmetry, plug it into the equation above, and then simplify. So we're going to plug 3 halves into the equation and then simplify, and we're going to get negative 6.25, which is equal to negative 25 over 4. So our vertex is 3 halves, negative 25 over 4. So let's just plot some of these points just so we're on the same page. We got our y-intercept, 0, negative 4. We have our axis symmetry, which is 3 halves, which is right around 1.5. Then we have our vertex, which is 3 halves and then negative 6.25. Right around there. Now we need more points to make this more of a understandable graph. So now we're going to take our other points. And remember, we're trying to find values of x that make the equation equal to 0. So we're looking for points that are going to cross the x-axis. So we want to end up with y values that are equal to 0. So let's start out with our vertex. And we're going to pick values to the left and right of 3 halves. So I'm just going to say negative, whoops, not negative, little bit less than 3/2 is just 1. Then we got 0. We got -1. I'm going to plug all those into the original equation. I'm going to plug all these numbers into this equation and see what they come out with. Alright, so now we're going to plot all these points that we just found. So we have -1, 0, 0, -4, 1, -6, 2, -6, 3, -4, and then 4, 0. I'm going to do my best to sketch this graph. And our solutions are where it crosses the x-axis. And where it crosses the x-axis, that's when y is equal to 0, which is right here and right here. So the solution to our equation is x equals -1 and x equals to 4. And we would write that as x equals -1, 4.